Now we have a point charge that's Q. We don't know what Q is, and we're interested in the electric field a distance 0.5 meters away from it. So we know that the electric field is 2 by 10 to the 4 newtons per coulomb. So let's apply the equation. We know that E equals 1 over 4 pi E naught Q over R squared. So 2 by 10 to the minus 4 equals 8.99 by 10 to the 9 times Q over 0.5 squared. So we end up with Q being 5.6 by 10 to the minus 7 coulombs. Now for part B, we can see that the electric field is proportional to 1 over R squared. That's what we call an inverse square relationship. So that means if we've got the charge here and we've got a E1 a certain distance away and an E2 a different distance away, so we'll call that R1 going to where the electric field is E1, and we have R2. The relationship we know is that E1 over E2 will be R2 squared over R1 squared. That's just another way of writing this relationship between E and 1 over R squared. So we want the electric field at the shorter distance. So that will just equal the electric field at the bigger distance times R2 squared over R1 squared. Now we know that R1 is half of R2. So R2 over R1 is 2. We square that, it's 4. So it's just E2 times 4. So at half the distance, the electric field will be 4 times as strong, and that would make it 8 by 10 to the 4 newtons per coulomb.